Dear learners, today, the focus of my presentation is parametric and non-parametric statistical techniques. Let us first try to understand what are parametric statistical techniques. Parametric statistical techniques are a category of statistical methods that make assumptions about the underlying distribution of the data being analyzed. These methods are characterized by their reliance on parameters, which are numerical characteristics that describe aspects of the population. The primary assumption in parametric statistics is that the data follows a specific probability distribution, often the normal distribution. Here are key components and concepts related to parametric statistical techniques. 1. Assumptions. Parametric statistical techniques assume a specific probability distribution for the data, commonly the normal distribution. 2. Parameters. These techniques rely on parameters, numerical values describing aspects of the population or probability distribution, e.g., mean, standard deviation. 3. Normal distribution. Many parametric tests assume a normal distribution of data. For example, t-tests and ANOVA are sensitive to normality assumptions. 4. Inferential statistics. Parametric methods, including t-tests and regression, are widely used for making inferences about populations based on sample data. 5. Hypothesis testing. Parametric tests are commonly employed for hypothesis testing. For instance, a t-test compares means to assess if there is a significant difference. 6. Efficiency and precision. Parametric techniques are often more efficient and precise when assumptions are met. They provide accurate estimates of population parameters with smaller sample sizes. 7. Central limit theorem. The central limit theorem is fundamental to parametric statistics, stating that the distribution of the sample mean approaches normality with increasing sample size. 8. Normality check. Researchers often assess the normality of data using tools like histograms, Shapiro-Wilk test, Kolmogorov-Smirnov test, skewness, kurtosis, histogram, box plot, PP plot, QQ plot, and mean with SD. One of the important parametric statistical technique is t-test. The t-test is a parametric statistical technique used to compare means between two groups, assessing if the observed differences are statistically significant or due to chance. It is commonly employed when the data are approximately normally distributed. Key features of the t-test. 1. Types. There are different types of t-tests, including the independent samples t-test for comparing two independent groups and the paired samples t-test for comparing related groups. 2. Assumption. Assumes that the data is approximately normally distributed. The test is robust to violations of normality with larger sample sizes. 4. Null hypothesis, H0. The null hypothesis typically states that there is no significant difference between the means of the two groups. Examples. Independent samples t-test. Scenario. Compare the mean scores of two groups, Group A and Group B, on an exam. Hypotheses. 0H0. There is no significant difference in mean scores between Group A and Group B. 1H1. There is a significant difference in mean scores between Group A and Group B data. Conduct a t-test using the exam scores from each group. Paired samples t-test. Scenario. Assess whether there is a significant difference in the pre-test and post-test scores of a group of students. Hypotheses. H0. There is no significant difference in mean scores between the pre-test and post-test. H1. There is a significant difference in mean scores between the pre-test and post-test. Data. Collect pre-test and post-test scores for each student and perform a paired samples t-test. Now let me discuss non-parametric statistical techniques. Non-parametric statistical techniques are a category of statistical methods that do not rely on assumptions about the underlying distribution of the data. Unlike parametric methods, which assume specific probability distributions, non-parametric techniques are more flexible and can be applied to a wider range of data types. These methods are particularly useful when the assumptions of parametric tests, such as normality, cannot be met or when dealing with ordinal or nominal data. Key features of non-parametric statistical techniques. 1. Distribution-free. Non-parametric tests do not make assumptions about the shape or parameters of the population distribution. 2. Data types, suitable for various types of data, including ordinal, nominal, and skewed distributions. 3. Less stringent assumptions, more robust to violations of assumptions, making them applicable in situations where parametric tests may be inappropriate. 4. Examples of non-parametric tests. Munn-Whitney U test, Wilcoxon rank sum test, used to compare the medians of two independent groups. Wilcoxon signed rank test, compares the medians of two related groups, paired samples. Kruskal-Wallis test, an extension of the Munn-Whitney U test for comparing more than two independent groups. Chi-square test assesses the association between categorical variables. 5. Hypothesis testing. Non-parametric tests involve testing hypotheses about the distribution or equality of medians rather than means. 6. Less powerful. Generally less powerful than parametric tests when the assumptions of parametric methods are met. Requires larger sample sizes to achieve comparable power. 7. Useful for small samples. Non-parametric tests can be valuable when dealing with small sample sizes, where the assumptions of parametric tests may be more challenging to meet. One of the important non-parametric statistical tests is chi-square. The chi-square test is a non-parametric statistical test used to assess the association between categorical variables. It determines whether there is a significant difference between the expected and observed frequencies in a contingency table. Key features. Purpose. Assess the independence or association between categorical variables. 2. Types. Chi-square test of independence, used when analyzing the relationship between two categorical variables. Chi-square test of goodness of fit, used to compare observed frequencies with expected frequencies for a single categorical variable. 3. Null hypothesis, H0, H0, there is no significant association between the variables, independence. Thank you. Don't forget to subscribe to my YouTube channel, Education and Teacher Education, at Shouking Bilal.